So very good morning, my dear students. I hope everybody is doing great. So you have done very well the second chapter called motion in a straight line. That's also called motion in one dimension. Now let's start the new chapter. The name of the chapter is motion in a plane. Okay. And this motion in a plane is also called as motion in two dimension, my dear students. Motion in what? Motion in two dimension. Okay. So I have given a simple introduction about a two dimension in the previous classes as well. Before moving into the chapter, in this chapter, the first topic is about scalars and vectors. All right. And scalars are the quantities which are having only magnitude but not the direction. That you also know. Vectors are the quantities will be having both a magnitude as well as direction. So those are the quantities are called vectors. And the very important thing is vectors are the quantities which obeys vector laws of addition. Vector laws of what? Vector laws of addition. So those are the quantities called vectors. Okay. So you might have finished so this scalars and vectors concept in the another track of the physics. All right. So you might have done it. Or you may be doing the last concepts of these vectors after finishing the vector laws of addition. Okay. Now, before moving into this vector laws of addition, and in these vectors, you might have learned about the basics, right? So that is addition of vectors. There are so many laws involved in it, and there may be the subtraction of the vectors topic also you might have done, subtraction, all right? And the most importantly, the vector resolution. What is that? The vector resolution also you might have done it. Okay. Now, so for your better understanding and it may be for a simple revision. So let us take a simple example, a numerical. All right. So there is a vector is given. So given, so a vector, listen carefully, a vector lying in xy plane, right? There is a vector lies in xy plane. So it has a magnitude of 3. So given it has a magnitude 3 and it is also given. And so this is making, right? So makes an angle. It makes an angle 30 degrees with x-axis. The question is, it is making 30 degrees with x-axis. Question is, find its components. What is that? Find its components along x-axis and y-axis, my dear students. So simple. So if you are comfortable with the topic called vectors, and you can easily do this, all right? So you can very easily do this. And let's see how to do this. A vector lying in xy plane. So this is not the vector lying in x-axis, and this is not the vector or lying in y-axis. Okay. So given vector not along x-axis or not even along y-axis. So this is in xy plane. So that means somewhere here. So the same thing I'm just drawing here, and before that, let me erase this part. Okay, so no confusions will be there. All right, let's come back. So this is the vector of my observation. So this is the vector of my observation, my dear students. Look at here. So this is the x-axis and this is the y-axis here. Now vector is lying along xy plane. So let me say there is a vector which is called a bar. A bar is a vector lying along xy, lying in xy plane. So it has the magnitude 3. So let me say this a bar vector will have magnitudes ax I cap plus ay j cap. What is this ax? Ax is the component of this a bar along x-axis. So let me say this is ax. So ay is the component of, what is that? Component of a bar along y-axis. And you know, in the given question, it makes an angle 30 degrees. It's clearly given, and let us say it is 30 degrees. Okay. Now, what is AX? AX is so simple. So the magnitude of this A bar is given as 3. So magnitude of this A bar is A, which is equal to 3. And this can also be written as modulus of A bar. Okay, and A, both are same. So you have the components concept. AX is equal to A cos theta. The component which is adjacent to theta, that is called cos theta component. Again, I'm telling you, the component which is adjacent to theta, so 30 degrees is here, adjacent to this theta is this one, right? Ax cos theta. And this is ay is a sin theta. The component other than adjacent side, so this is called y-axis component, is a sin theta. So simple. So what is ax? My dear students, A is 3 into cos 30 degrees. So Ax is 3. 3 into cos 30 degrees is root 3 by 2. So Ay is what? Ay is A sin theta. A sin 30 degrees. So what is sin 30? Sin 30 is 1 by 2, right? I can write it is 3 by 2. All right? Clear? So for your better understanding, so what I'm going to do here is, let us find the magnitude of this, because you have a x value and a y value. So let us find the magnitude of this. So magnitude of this a bar vector is equal to square root a x square plus a y square. So don't ask me how you got this formula. This is the formula you might have learned in this vectors topic, right? It must have finished by this time. Okay. So now let us find the magnitude. Square root ax is how much? 3 into root 3 whole square. So that is 3 square 9. Root 3 square is 3 by 2 square is 4. That is ax square. Okay. Plus ay square. What is ay square? 3 square is 9 by 4. Okay, my dear children. So I can take common 9 by 4 inside the square root. So it is 3 plus 1, right? 3 plus 1. It's 4. 4 cancel. Root 9 is what? 3. So what is the magnitude of this A bar? It is 3. What is the magnitude of this A bar here? It is 3. All right. Clear? So that's it. So like this, the numericals, you might have already studied, but still I'm just revising, and it is a quick recap for you so that you will be understanding the further parts of the chapter easily, especially, and this is the topic is based on what? This one, vector resolution. Vector resolution. Okay. If any vector is there along x-axis, you cannot resolve this. If any vector is there along y-axis, you cannot resolve this. If any vector is lying along in xy plane or yz plane or zx plane, you can resolve it into the two components. Understand? Clear? Now, and one more important thing I would like to inform here. What is this ax I cap and ay j cap, right? So I cap and j cap are the unit vectors, my dear children. I cap, so let me write here itself. I cap and j cap are unit vectors, right? So when I say I cap, it is the unit vector along x-axis. When I say j cap, it is the unit vector along y-axis. So the unit vectors whose magnitude, what is the magnitude of the unit vector? I cap magnitude is how much? J cap magnitude is how much? K cap magnitude is how much? 1. The unit vectors are the vectors whose magnitude is 1. Clear? Now, let me draw a line here so that I can give you a question to solve on your own, right? So, are you ready? Are you ready now? Let me give you an example question. So, this is the class work question for you now. So, there is a vector is given, my dear students, right? So, there is a vector given. This is x-axis and y-axis. And here there is a, sorry, this is the xy plane. So there is a vector called p bar, fine. And this p bar is making an angle theta along x-axis. Then this will be 90 minus theta. That will not be discussed. Okay, you should understand if it is theta, so the other angle will be 90 minus theta. Now they have given this component is 5 and this component is 6, right? Now the question is find the magnitude, find the magnitude and the direction, find the magnitude and direction of p bar, right? You know how to find the magnitude. So p bar can be written as px into I cap plus py into j cap. So px is given how much? 5. Py is given how much? 6. So you can find the magnitude and you can also find the direction. How to find the direction of this? Direction of this is, if you know this, direction finding is very simple. So that direction we'll find in the previous case. Let us see here. So that this direction is 30 degrees. Okay. So the direction is, I can find by using this formula. Tan theta is equal to ay by ax. So from here, theta is equal to what? Tan inverse ay by ax. So that is what? The direction. As we are talking about the direction, it's a vector. It will have both magnitude as well as direction, my dear students. All right. So you just do this and send me your solution right now. Okay. Now, let's see one more example, my dear children here. So let's see one more example. One more example. The question is, so there is a given vector, let's say it is a bar is equal to I cap plus j cap. Simple, I cap plus j cap. What is I cap? Unit vector along x-axis. What is j cap? Unit vector along y-axis. Okay. So the question is, what is the magnitude of this vector, right? So find the magnitude of a bar. Magnitude of this a bar is what? Mod a bar, which is equal to square root ax square. So what is here? What is here? So ax is 1 square plus ay, it's also 1 square. Understand? Because this value I can write it as 1 into I cap plus 1 into j cap. Understand? So quotient of this I cap is 1. Quotient of this j cap is 1. So whereas, let us take this equation, whereas quotient of I cap is ax, quotient of j cap is ay. So here, quotient of I cap is px, quotient of j cap is py. Alright, so this can be written as root 2. Right, so root 2. So the magnitude of a bar is what? Root 2. Okay, so like this, the numericals also will be asked. Clear? Now, just a second. Just a second. Okay. All right. Let's continue. The first topic of today's session is position vector, right? So next we will be discussing about a displacement vector. What is this? A displacement vector. After that, we'll discuss about a velocity vector, so then acceleration vector, and numericals we will solve. So this is the basic session. Okay, so today, so the basics of motion in a plane we are discussing. Okay, so let's start the position of the vector. What is the position vector? What is the displacement vector? Now, all right, you ready? Yes. Let me take the another page here. Now, so what is the topic, my dear students, here? Position vector. What is that? Position vector and displacement vector. Both together we are going to discuss. Position vector and displacement vector. Start. Let me take a plane which is xy plane. There is a point called x1 comma y1. You know this, why it is called x1 comma y1. See, along x-axis, so it is at a position x1 from the origin. Along y-axis, it is at a position y1 from the origin. So this is point P1. What is this point called? P1. You can see, so this is the point P1. So this is called position vector. Position vector is denoted with the symbol R. So as this is my first position, I am writing it as R1 bar. So it is so simple. I am writing here R1 bar is the position vector, and which is defining the position of the particle P1 in this plane. So the position of that particle is represented by this position. Now, another particle, let me take, it is P2. Okay, particle is at this position and its coordinates are x2 comma y2. We know the coordinate system. So x2, so this is x2. Okay, from origin to here. So this is y2 from origin to this point. No confusions, right? So this position is represented by the vector called R2 bar, no confusions. So R2 bar is the position vector which is representing the position of the second particle, or the same particle is moved from P1 to P2, remember. So position vector representing the second position of the particle. This is first position and this is second position. Now, look at the interesting thing here. This R1 bar will have its own components, own rectangular components. So the same thing, let me write here, R1 bar. R1 bar is equal to, this is x1 I cap plus y1 j cap. So this can also be written as in the position vector form. So R2 bar also I can write. So what is the component here along x-axis? So this is x2 I cap plus y2 j cap. So this is R1 bar and R2 bar positions. Okay. Now, this particle is moving from P1 to P2 in this way. Carefully see. P1 to P2 in this way. So this is what P1, P2 bar. You know what is this P1, P2 bar? Did you try to recollect the concept of displacement? What is a displacement, my dear students here? Displacement is the shortest path between initial position and final position. Shortest path is what? Shortest path is what? Shortest path is the straight line path always. And let's see. This is P1 and this is P2, and shortest path between these two is a straight line. Yes, this is called the displacement. As it is a vector, its direction is always from initial point to the final point, my dear children. Initial point to the final point. Okay. So now this is the vector called displacement vector. So the same thing, let me write here. P1, P2 bar is equal to a displacement vector. Now the displacement vector concept is done and the position vector concept is also done. So let us find the expression for this displacement vector, right? So what we are going to do is finding the expression for the displacement vector. Now, so there is a triangle is formed here. You can see O, P1, P2, O. So in this triangle, so you can use, so let us use vector. Let us use vector laws of addition. So that I can also say triangle law of vector addition tells that R1 bar plus P1 P2 bar, right? So the sum of these two sides R1 bar plus P1 P2 bar, which is equal to, right? So what is, which is equal to what? So the opposite side of the triangle, you can see these R1 bar and P1 P2 bar are in the order, you can see. So this is my R1 bar, so this is my P1 P2 bar, they are in the order. So which is equal to the sum is equal to the opposite side, whatever is given in the opposite side. It is not in order, you can see R2 bar is the closing side of this triangle, which is kept in the opposite order, right? So that is equal to R2 bar. You might have learned this in vector law, triangle law of vector addition. Okay, so from here, so what I can write, so your P1 P2 bar is equal to R2 bar minus R1 bar, my dear students. So this I can also write delta R bar. You can see the change in position vectors R2 bar minus R1 bar. So that is delta R bar. Okay. So what is delta R bar? Let me write once again. My delta R bar is equal to a displacement vector, my dear children. So the displacement vector is R2 bar minus R1 bar. What is R2 bar? So this is my R2 bar. This is my R1 bar. R2 bar is what? X2 I cap plus Y2 J cap, right? This is R2 bar minus R1 bar X1 I cap plus Y1 J cap. So I can say finally change in this displacement, change in position. Okay, displacement vector is equal to x2 minus x1 into I cap, because I cap you take common, so plus y2 minus y1 j cap. So that is I cap and j cap components of what vector? Components of the position vector. All right, clear? So this is what the components of displacement vector. This is the displacement vector, and these are the position vectors. These are the position vectors. Clear? Now displacement vector we know and position vectors you know. So this I can also write it as x2 minus x1 can be written as delta x, because change in position along x-axis into I cap plus change in position along y-axis is delta y into j cap. So this is what the delta r. Okay, clear? Now let's concentrate on average velocity. What is that? Average velocity. Velocity is a vector quantity and average velocity is also a vector quantity. So that is V average bar. Everything we are talking about velocities. And this average velocity can be written very easily. You know, average velocity is total displacement by total time taken. So I am writing here average velocity is equal to total displacement. It is delta r bar by delta t. Okay, so what is delta r bar? Delta x into I cap plus delta y into j cap. See, this r bar, delta r bar we wrote here. So which is divided by delta t. So this can also be written as individually delta x by delta t I cap plus delta y by delta t j cap. Okay, so this is the average velocity formula. What is this formula called? Average velocity formula. Now, we know when we apply limits for this average velocity, limit delta t tends to 0 of average velocity. See, we know the concept of application of limit here. When we apply limit for this average velocity, it will give you the instantaneous velocity. What is that? When you apply limit, see once again, so limit, so when delta t value tends to be 0, when time interval is very, 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 very less, this average value is what? Delta x by delta t into I cap plus delta y by delta t into j cap. Carefully see, my dear students, here. When you apply the limit to this, and it will become differentiation, right? This we had already discussed in the last sessions in motion and a straight line also. When delta x by delta t, when limits are applied for this, when the limits are applied for this, when time is tending to 0, so the delta x by delta t will be dx by dt of I cap plus, so what is that? Delta y by delta t, it's a dy by dt of g cap. Okay, so now the final value is what? So this is instantaneous velocity, my dear students. So this, when you apply limit delta t tends to 0 to average velocity, you got an expression for instantaneous velocity. What is instantaneous velocity here? So dx by dt is vx instantaneous velocity along x component into I cap plus Vy instantaneous velocity along y-axis into j cap. Okay, so this is the concept of instantaneous velocity. Okay, what is this concept here? Instantaneous velocity. Any confusions here? In this instantaneous velocity, what we had drawn just now in this instantaneous velocity, let me draw a line here. In this instantaneous velocity, what we had written, Vx is equal to dx by dt, and Vy is equal to dy by dt. So let us talk about directions of this instantaneous velocity and average velocity. So what is the average velocity here? Look at here. Delta r by delta t is the average velocity. As average velocity is a vector quantity, this delta r is also vector quantity. Delta r is what? Position, sorry, displacement vector. So this average velocity is always directed in the direction of displacement vector. What is the direction of displacement vector in our diagram? So this is the direction. So your average velocity also directed in the same direction. Okay, clear? But instantaneous velocity is not like that. So imagine a situation where x-axis and y-axis are like this. X-axis and y-axis are like this. So the particle is traveling like this. At this particular point, if you want instantaneous velocity, so you need to draw the tangent. That's it. That is instantaneous velocity direction. So at any point in the path of the particle, if you want to find instantaneous velocity at a particular time instant, okay, so you need to draw the tangent. So that's okay, fine. Finally, instantaneous velocity, I'm writing here, listen carefully. Instantaneous velocity is equal to Vx, which is dx by dt I cap, carefully see, Vx I cap plus Vy j cap. So this is the expression for instantaneous velocity, my dear students. And if I represent this in terms of the graph, this is x-axis and y-axis. Imagine this is my velocity vector, which is called instantaneous velocity vector, the same thing. Okay, so here this v bar is making an angle theta with the positive x-axis. So in this case, what is the x component of velocity here? Vx is equal to, can I say it is v cos theta? Definitely. And this is Vy. What is Vy here? So can I say it is V sine theta? Yes. So here, so the magnitude of this V bar, what I can write? Square root of Vx square plus Vy square. So it's the magnitude. And the direction it is theta is equal to tan inverse of Vy by Vx. So that is the direction of this vector. Okay, so that's what velocity, instantaneous velocity vector and average velocity vector. In the same way, if you know this, from here you can also find the acceleration topic, my dear students, right? So from here, look at here. So from this, you can also find the acceleration topic. What is the acceleration topic here? So instantaneous acceleration can be find in this way, a bar. Okay, so can be find in this way. So what is instantaneous acceleration? It is dv bar by dt. Yes or no? Differentiation of velocity is called acceleration. So this I can write d by dt of instantaneous velocity is what? Vx I cap plus Vy j cap. So this, this d by dt of Vx. So a bar is equal to a d by a dt of Vx I cap plus a d by a dt of Vy j cap. So this I can write it as differentiation of velocity along x-axis. You get acceleration along x-axis plus differentiation of velocity along y-axis. You get acceleration along y-axis, ax I cap plus ay j. Okay, clear? Just fine. All right. So, my dear students, here we have finished instantaneous velocity and instantaneous acceleration. So, let me write the expressions over here. So, delta r bar, it is the displacement vector, which is delta x I cap plus delta y j cap. So, here itself, instantaneous velocity is Vx I cap plus Vy j cap, and instantaneous acceleration is Ax I cap plus Ay j cap, right? So what is Vx, what is Vy, what is Ax, what is Ay, you should know, right? So let me write in detail. Vx is equal to dx by dt, Vy is equal to dy by dt. What is velocity? Instantaneous velocity is what? At a particular instant, position of the particle. At a particular instant, position of the particle. This is position of the particle along x-axis, position of the particle along y-axis. So same way, Ax is equal to dVx divided by dt, and Ay is equal to dvy by dt. So this is instantaneous velocity and instantaneous acceleration issues topics here. Okay. So this is the topic of our discussion today. Let's solve a few numericals based on this, based on today's session itself. Okay. Let's look at the question. So the question is, given position of a particle. Okay, see here, r bar. R bar is given as 4t square I cap plus 2t j cap. So this is position of the particle. Position of the particle is in meters they gave. So where ct, time is given, t is time in seconds, no confusions. Question is, find the acceleration of the particle. Find the acceleration of particle. Acceleration of the particle. Simple. How to find the acceleration of the particle? We have position vector. You can see we have the position vector. So this position vector, if you differentiate, you get velocity. And you another again differentiate the velocity, you get acceleration. It's so simple, right? So what I'm going to tell you is, first instantaneous velocity, if you want to find, you need to do the differentiation of this position vector. Okay. So you this is what the velocity and acceleration you get. So if you differentiate this instantaneous velocity, this is v bar. Simple. Understand? So let's differentiate, get velocity. V is equal to a d by dt of r bar. R bar is what? 4t square I cap plus 2t into j cap. So what I can write here? So d by dt of 4t square, it's 8t I cap plus d by dt of 2t j cap. So that is d by dt of 2t j cap, it's a 2 j cap. Okay, so this is what the velocity, my dear students. Now acceleration, you get it as d by dt of velocity. What is velocity? We have got 8t I cap plus 2 j cap. So that is d by dt of 8t, that's 8 in I cap plus d by dt of 2, 0, 0 into j cap, it's 0. So what is the answer? 8 I cap. Okay, acceleration. What is the SI unit of acceleration? It's meter per second square. All right, clear? So what is the acceleration? 8 I cap meter per second square. So is it constant or depending on the time? This is the acceleration, we have got it as constant. It is independent of the time you see. Whatever may be the time value you put in this, so it's constant. It is moving along positive x direction. Acceleration of the body is constant, moving along positive x-axis. Because see here, it's not moving in a plane. Acceleration is 8 I cap, means along positive x-axis, right? So that is the concept. Now, are you ready to solve next question, my dear students? Are you ready to solve the next question? The next question is, look at this. Given V bar is given 6t cube I cap plus p square j cap. So that is meter per second, because velocity is given in meter per second. Now you need to find the acceleration at, right, acceleration at t is equal to 2 seconds, right? So you need to find the acceleration at 2 seconds. So can you find it? So this is the class work. Simple. What is the acceleration formula? Here I have told you a is equal to d by dt of v bar. So this is instantaneous velocity. This is instantaneous position. Okay. Everything is instantaneous, only they gave. Okay. Now, so let's see the another numerical. Before that, I'll take the a new page. Let's have a look at this example. Given position of a particle, r bar is equal to 3t j cap plus 2t square, sorry, that's I cap. R bar is equal to 3t I cap plus 2t square j cap plus 5k cap. And here also t is the time in seconds. Question is find velocity as a function of time and acceleration as a function of time. Okay, and there is another question is also involved in the same question. Find magnitude and direction of velocity, which is a function of time, at t is equal to 1 second. Okay, so that's the question we need to solve right now. You ready? So simple solution is there. What is R bar? It's a position, instantaneous position of the body, right? So what is that? Instantaneous position or location of the body. Instantaneous position or location of the body. Okay. So velocity with respect to as a function of time, you can easily find out. So V bar is equal to a d by dt of R bar. Just now we discussed. So d by dt of R bar is what? 3t I cap plus 2t square j cap plus 5k cap. Okay. So from here, so d by dt of 3t, that's 3 I cap plus d by dt of 2t square, so that's 4t j cap. So d by dt of 5 is 0, 0 into k cap is 0, so that's a velocity. See, velocity is also a function of time. So don't think that there is no time is involved in this equation. There is a time t is involved in this equation, my dear students. It's time t. Okay. Now, same way, acceleration also let us find a bar is equal to d by dt of v bar. So a d by dt of v bar. What is v bar, my dear children? Here 3 I cap plus 4t j cap. So d by dt of 3 I cap plus 4t j cap. What is d by dt of 3 I cap? D by dt of 3 is 0. 0 into I cap is 0. Okay. Plus d by dt of 4t j cap. Carefully see. d by dt of 4t j cap. d by dt of 4t. 4 is constant. d by dt of t is 1. So I can say 4 into j cap. What is acceleration here? 4j cap. It's meter per second square. So can I say acceleration is constant? Yes. It is moving in which direction? Tell me. Tell me, what's the direction of acceleration of the body here? So my question is, it is also a class work. Right now, send me the solution. What is the direction of acceleration of the particle? Okay. Now, let's continue. This is acceleration with respect to time, velocity as a function of time. So find the magnitude and direction of velocity. Okay. So how to find the magnitude and direction of velocity here? What's the magnitude? See, we know we have got it as v bar is equal to 3 I cap plus 4 t j cap. So at 1 second time, so this will be 3 I cap plus 4 j cap. So what is the magnitude? V bar mod, which is equal to 3 square plus 4 square. So this is 9 plus 60. So this is root 25. So I got it as 5 meters per second is the magnitude of the velocity is done. Okay. So I can see this is a light color. Let's take a red color. So V is equal to 5 meter per second here. So now the question is finding the direction of the velocity, right? Direction of the velocity. So direction of velocity finding is also very simple, my dear students. So if you draw, this is the x-axis and y-axis here. So this is the velocity vector, for example. Velocity vector is what? So I have at 1 second, okay, at 1 second, it is 3 I cap plus 4 j cap rho, okay. So this is the theta here. Theta is the angle made by this velocity vector with x-axis. So from here, tan theta is equal to, what is that? Tan theta is equal to Vy by Vx, right? So what is the component along y-axis? So this is the component along y-axis. It's 4 divided by, what is the component of I cap? Sorry, what is the quotient of I cap? So it's 3, so 4 by 3, right? Why? Because V bar is equal to Vx I cap plus Vy j cap, my dear students, no confusions. So from here, what I can write, tan theta is equal to 4 by 3. Tan theta is equal to 4 by 3. So there is a triangle here, 3, 4, 5 triangle. What is that? 3, 4, 5 triangle. So important and easy concept, 3, 4, 5 triangle. Imagine you have a triangle like this, all right? So this is perpendicular to each other and this is, let me say, 37 degrees. If it is 90, if it is 37, so this value must be 53 degrees. So 3, 4, 5 triangle, 37. First number is 3. So opposite side you fill it with this 3. Adjacent side it is 4, 3, 4. And according to the Pythagoras theorem, you get this hypotenuse as 5. Remember this triangle. From this triangle, I can say tan 53 degrees. What is tan 53 degrees? Tan 53 is opposite side by adjacent side. Tan 53 opposite side is 4. Adjacent side is 3. Okay. So tan 53 is 4 by 3. Tan 53 is how much? 4 by 3. So in the same way, I can say tan 37 is how much from this triangle? It is 3 by 4 because 37 is here. Tan 37 is opposite side by adjacent side. It's 3 by 4. So can you tell me sine 37 from this triangle? Can you give me cos 53 from this triangle? Can you tell me sine 53 can this from this triangle? Can you give me cos 37 from this triangle? Sine is opposite side by hypotenuse. Cos is adjacent side by hypotenuse. You give me these values as classwork. Do it now only. Right? Pause the video and send your answers. Come back to our question. What is theta? They asked. Theta is equal to tan inverse of 4 by 3, my dear students. So what is tan inverse of 4 by 3? 53 degrees. Yes or no? This 53 is equal to 4, tan inverse of 4 by 3. So theta is equal to 53 degrees. So this is a very important triangle. Very, very important triangle which will be useful for us. Keep on in all your +1 and +2 topics. Okay, so in this way, so we will be discussing this chapter and next chapter. Next concept we are going to learn is, you might have, you have studied the equations of motion, right? How to use the equations of motion in two dimension. This is the two dimension. And projectile motion. This is our next topic, my dear students. Right? So get ready for your assignment. All the best. Thank you so much.